Oh, hello there. I hope that was cringy. Yesterday was May the 4th, so this is pretty accurate or pretty appropriate. But anyway, let's get right into this. This is week 5 superposition. This is explainer video number 17.53, and let's go over the learning objectives. And there is none. Professor Tano didn't post any for this week, so I'm just going to go ahead and make my own. I'm going to go ahead and say that the learning objective for this week is to measure the speed of sound in oxygen, which is pretty cool, right? Anyway, let's get right into it. So before we start, I'm going to start off with this interesting fact. Why do we all hate calculating frequency? I'll let you go ahead and take a minute to figure that one out. Alright, if you guessed that it's because it's so easy that it hurts, you're a nerd. Congratulations. Alrighty. In 1886, a German scientist named Adolf Kuhn. Get out. My dog just walked in. Anyway, he developed a technique for accurately measuring the speed of sound in various gases. And so basically, a long tube known today as the Kuhn's tube has a vibrating piston at one end and a closed end at the other. And there's finely ground particles of cork that are sprinkled at the bottom. And then when the piston vibrates, there are a few positions where the corks seem to gather up into little small piles, and it looks something like this. So the question asks, what is the speed of sound in oxygen? Now, when I first read this, I was like, how the heck am I going to find the speed of sound in oxygen? Well, here's how we do it. So we need to know some things before that. So we know that sound is moving air, right? So if there's no moving air, then the cork won't move. That makes sense. So if the cork is not moving or stops moving, at that point we can start considering it a node. So a node is basically when there's no movement or it's a flat line. So right here, if we can imagine a wave going up and down, right here would be flat, where they would meet. So let's start off with some given things. We know that the distance between these four piles is 123 centimeters. We're going to go ahead and convert that to meters right off the bat, because why not? And then we know that the frequency is 400 hertz. That's given to us in the question. And then from the book, we know that the distance between two piles or two nodes is lambda over 2. So the distance between this node and this node would be lambda over 2, this total distance. And then we know that the distance between nodes, like the distance between here and here, like in between them, the distance to get in between them is 1.23 divided by 3, if that makes sense. So we have 4 of them right here that span 123 centimeters. You can divide that by 3 and you'll get a point here, a point here, and a point here. So we're splitting all the nodes in half. And then we know how to calculate the speed of a sound wave, which is just V is equal to the frequency times lambda. So we know the frequency, so we just need to find lambda. Alrighty. I know it's a lot. Just hang in there. So, this is the final step. It's literally not that hard. So we're going to go ahead and just solve this final equation from over here. This is 1.23 divided by 3. We're going to solve it over here. So 1.23 divided by 3 is equal to 0.41. This is the distance between the nodes, the halfway point between those two nodes. We can set that equal to the distance between the piles, which was lambda over 2, because they should be the same distance, 0.41. So now we just got to multiply both sides by 2 to get lambda by itself, and then we get 0.82 meters. That's lambda. Now we literally just plug it into our velocity equation right here. So 400 hertz times the 0.82 meters, and we get our final velocity is equal to 328 meters per second. And meters per second is correct because hertz, the unit for hertz is 1 per second. So if we have 400 hertz, that's 400 per second. And we're multiplying that by 82, seconds on the bottom, so meters per second. Alrighty. And that's it. Pretty cool, huh? And just in case you're curious, that answer is pretty spot on because I looked it up on Google and it says 326. So I call it a win. Alright, thank you.